Hi everyone, welcome to MongoDB's session on smart, secure and scalable building AI agents with MongoDB on Azure. To take you through this session, I am 𝗦𝗲𝗀𝗀𝗀, Advisory Partner Solutions Architect at MongoDB. In this session, we will explore the challenges faced by developers while creating agentic AI applications and how MongoDB and its integrations with Microsoft services helps in the entire cycle from building the prototype of an agentic AI application to finally taking it to production. So let's dive into the section. Let's meet Anna, our pro developer who has started to design an agentic AI application. She has put down her requirements but is perplexed as she realizes that she has all types of data which needs to be used by the agents in a meaningful way. This includes images, videos, PDFs, and even vectors so that they can be easily fed to the models for accurate responses. Also, as the app is for a regulated industry with large global presence, she confirms that she would need a highly flexible database with core architectural strengths. Also, she figures out using a separate database for searching the operational database would add complexity and latency. So she would need a strong search capabilities embedded into the transactional database itself. So Anna does her research, asks Gen AI tools like ChatGPT, and decides that MongoDB is the best fit for her agentic application. Being a document database, it is inherently flexible and dynamic. It allows you to store all your operational data of varied structures along with its metadata and vectors. You can easily leverage the Voyage AI embedding models, which are known to provide the most accurate results. You can use built-in vector search or hybrid search depending on your need. Built on the strong pillars of security, scalability, and reliability, MongoDB is known for its architectural excellence. Its strong integrations with cloud and various AI partners makes it easily pluggable in all agentic frameworks. Here is a typical RAG workflow that is centered on MongoDB Atlas. On the left side is the ingestion process, which pre-processes different data sources, stores the data, metadata, and its associated vectors into MongoDB Atlas. On the right side is the query process, wherein the answer to the query is returned by the LLM by taking into account the results from MongoDB Atlas similarity search, thus providing for contextual and accurate responses. Now let's look at two quick demos showcasing the power of MongoDB Atlas for storing and searching multimodal data. First demo is a car manual search which showcases all the three types of search MongoDB supports. First, we search check engine light using Atlas keyword search, which does an exact keyword or phrase search with fuzzy matching and provides results where it finds exact matches. But if we ask a question like how do we start a car in early morning, keyword search may not provide for the best results. Here we use vector search to search based on the semantics of the query, which provides for more contextual answers. This can be further enhanced by using hybrid search, which uses MongoDB's native $rank fusion to bring together the best of both worlds. The second demo highlights multimodal search with MongoDB. You can search for similar claims from MongoDB's claim database by uploading the image of a damaged car. The engine returns similar claims and its images, severity, and the cost associated with the historical claim. Based on these similar claims, an estimated cost is calculated. You can do the same by describing the damage in text instead of uploading a photo. The similar claims with images, severity, cost is returned and which again is used to calculate the estimated cost. Lastly, Atlas charts show the properties of the claims database like severity and claim amounts. Now Anna is happy that she found the right database. However, she knows that 70% of Gen AI experiments do not make it to production. She is now thinking about how to start the agentic app build in the most efficient way that will ensure the prototype will be led to production. She needs to evaluate and deploy the right models, add MongoDB Atlas as a knowledge source, add other external sources that can perform actions. She needs a robust SDK along with responsible AI features which cannot be compromised in production. Anna selects AI Foundry to help her build her AI agents as it has all the building blocks required for her to design, build, and manage her AI apps and agents. Foundry has 11,000 plus frontier and open models. It has the agent service, which helps build simple agents to advanced multi agent workflows and offers a seamless way to integrate external data sources like MongoDB easily into its AI ecosystem. It integrates with her IDE and also provides for evaluations, model fine tuning, monitoring, and governance along with robust safety controls. MongoDB MCP server is integrated out of the box in the AI Foundry tool itself. You can select it from the tool catalogs menu. Once you select the MongoDB MCP server as your tool, you get the option to host the MCP server in Azure Container Apps using a pre-built bicep template. Once the MongoDB MCP server is hosted locally in your Azure environment, you can use any of the tools that are available in the MongoDB MCP server, including CRUD operations and admin tasks. Let's check out the integration in an Agents Playground demo. Once you have added MongoDB MCP server and selected the tools that you want to use and have given the instructions to the agent that it needs to answer based on MongoDB movies collection, we can ask simple questions like the top rated movies of 2011. It's a simple MQL find operation which brings the top rated movies. Now we can ask a follow-up question as to what were their ratings, and because the chat has the context from previous question, it will provide the IMDb ratings from the movies collection. Now let's ask a more complex question like retrieving the movies of genre horror and has scenes picturing a mother and child. Now it answers the query based on semantic search on the vectorized plot column, which has the detailed plot of each movie. We can verify the tool used by the agent using trace and logs, but here let's ask the model itself as to what search was performed to answer the query, and it confirms that a vector search was performed against MongoDB. AI Foundry with MongoDB helped Anna build the prototype easily, and now she's planning to take her agentic app to production. But she realizes that given their regulatory and compliance requirements, managing security from within the database alone would not be enough. It needs to be managed from their centralized SIEM, security information and event management tool, which has a 360-degree security view of their entire software estate. Anna's enterprise uses Microsoft Sentinel, a cloud-native SIEM, SOAR, UEBA, and threat intelligence tool that is available in the Microsoft Defender experience with Gen AI. With over 350 plus data connectors, it can support the full SecOps life cycle. It's fully managed, scalable, and secure with rich tooling that enables security operations to manage and analyze security data, detect threats, and automate responses. MongoDB Atlas is available as a data connector in Sentinel. The connector solution can be set up using Marketplace or Content Hub. Once you deploy the MongoDB Atlas data connector, it spins up an Azure function that retrieves the MongoDB database logs for the specified Atlas project and clusters. It will apply the data collection rules, DCR, and ingest the logs into the log analytics workspace tables using the log ingestion API. These logs are then at the disposal of the users to create workbooks, queries, etc. using KQL, custom query language, or automate response actions using logic apps. Time for a demo. This is how MongoDB Atlas solution for Sentinel appears on Azure Marketplace. You can click on Create to deploy the solution. And once you provide an existing resource group and the log analytics workspace and click on Create again, the solution will be deployed. Then you can find the MongoDB Atlas data connector in the workspace where you had installed the solution. Open the connector page and click on the Deploy to Azure button to deploy the MongoDB Atlas data connector. In the Basics tab, provide the resource group and the workspace ID. On the Next tab, provide MongoDB project and cluster details. Next, select all the log categories that you want and then confirm the frequency at which the logs needs to be pulled into Sentinel. Finally, review and click on Create to deploy the connector. This will deploy the Azure function, the storage accounts, the DCE, DCR, key vaults, etc. We can go to the Azure function and check its invocations. On refresh, you can see that the function was invoked based on the frequency that had been set, and in this case, which was 5 minutes, and logs have started flowing into Sentinel. In Sentinel, you can see that a custom log table was created for MongoDB Atlas logs. You can query the table using custom query language or even create a workbook, add a query to the workbook, and then we can also attach a visualization to it. Okay, great. That was seamless. But Anna is now also worried about scalability as she knows that the global user presence will have a uniform growth throughout the year and exponential growth during the holiday season. She needs a database that can scale well based on the demand. She also wants to ensure that the database is deployed in production using best practices of networking, security, etc. Else it might raise compliance issues and also make governance difficult. Anna learns about Azure Landing Zones, which are blueprints for deploying workloads in a consistent and well-architected manner. It covers 8 design areas and provides templates for deploying infrastructure as code. MongoDB Atlas has published its Azure Landing Zone Accelerator, which contains Terraform templates for both single region and multi-region deployments of MongoDB Atlas. It also enables GitHub Actions for DevOps and is integrated with Azure Monitoring for watching metrics from Atlas clusters set up using Landing Zone Accelerator. A multi-region deployment of MongoDB Atlas using an Azure Landing Zone Accelerator will deploy the MongoDB Atlas cluster with multiple nodes in multiple regions. It will set up private endpoints and a private link with the application VNet, which also hosts the network security group and the NAT instance for security. VNet peering is enabled for resiliency so that in case of a regional outage, all remaining regions have visibility to the rest of the MongoDB Atlas cluster nodes. For observability, an Azure Function app is deployed that periodically queries the MongoDB Atlas admin API to gather database health and performance metrics, which are visualized by the application insights dashboards. All this is implemented using Terraform modules and GitHub Actions to enable infrastructure as code, automation, DevOps, and repeatable deployments. Let us now see the single region deployment of MongoDB Atlas cluster using the Landing Zone Accelerator. Similar steps are to be followed for a multi-region deployment. After doing the basic DevOps setup, we can go to GitHub Actions and select single region deployment workflow to create the basic MongoDB Atlas infrastructure and the infra that is required for an application to test the database connectivity. Once the Terraform plan is run, a manual approval step creates an issue wherein the authorized approver has to comment yes for the pipeline to run Terraform apply. Now the issue is closed and we can verify each step's execution in detail in the workflow run. Now, with both workflows complete, we are finished with the deployment of all the infrastructure for MongoDB Atlas cluster and the test web application. Next, we select deploy application code action, which has two workflows. One, to deploy the code which pushes Atlas metrics to Azure Application Insights workspace, and second, to deploy the web app to test the connectivity from web app to MongoDB Atlas via the private link. Once both the codes have been deployed, we can go to the test application, click on its URL and check if the connectivity to Atlas was successful. We can then go to Azure monitoring and see if MongoDB Atlas metrics have started to flow in. Great. Let's summarize. We saw how MongoDB Atlas flexibility combined with AI Foundry made RAG seamless and allowed for creating agents grounded in MongoDB Atlas data, allowing for minimal time, cost, and complexity. We also saw how MongoDB Atlas inherent architectural strengths augmented with Microsoft Sentinel and Azure Landing Zones met the enterprise-grade security and scalability requirements, and thus eventually enabling agentic AI apps to move from prototype to production. In this short time, we touched upon the four critical tenets for building a robust agentic AI app, namely the database, the tooling or the platform, security, and scalability. So Anna is happy with her agentic AI app finally in production. And I hope you too are happy as this session was useful to you in your efforts to build the next innovative agentic AI app. Thank you for your time today.